Okay guys, time for an update about our very exciting visit to the DKRZ, or the Deutsche Klimarechnungszentrum, or the German Climate Computation Centre. So this is a German institute. They own a supercomputer that is basically full-time used for Earth sciences.
Everything changes.
So, and what does it mean to be a supercomputer? It's pretty impressive. It's the third fastest computer in the whole of Germany and the 34th fastest in the entire world. The thing has 100,000 computation cores. So just to give you an idea, your typical computer, your typical laptop has maybe 4 or 8 cores, and that's already a good one. And secondly, it has 240 terabytes of RAM memory, and your typical computer has something like maybe 8, or if it's a very good one, 16 gigabytes. So this is pretty impressive. So these simulations also create a lot of results. That's a lot of data, and the computation center basically has a whole floor full of data storage. It's about 190 petabytes full of data storage. So, and petabytes is terabytes with another 3 zeros behind it. It's just huge. So that's pretty impressive. Now, it will not come as a surprise, but all this computation power also produces tons and tons of heat. And actually, the heat is reused to heat the building in winter. And the rest of the electricity consumption comes from renewable sources, because in the end it would be quite ironic to have a computation center that runs simulations on climate change and that would use dirty electricity, isn't it? So there is one important thing to keep in mind first, and is that these are simulations. So what the researchers do is they come up with a bunch of scenarios which are based on different assumptions for how the population of the world is going to change, what is going to be the economic growth, what is going to be the oil prices, what is going to be the evolution of technology, and so on. And based on assumptions for all those parameters, they come up with different scenarios, and then they will be simulated. So, and there's 2 scenarios that are quite famous and that you have to look out for in the simulation results that I'm going to show you. And that's the RCP 2.6. Don't bother too much about this code. Just remember that this is the scenario at which we will keep global warming below 2 degrees Celsius. And that's indeed what the international agreements, the Paris Agreement, aim for. And then there is the RCP 8.5 scenario, which is the business as usual, as they typically call it. This is what would happen if we don't do anything special now, if we don't take any climate action, and if we would just continue polluting the way we are. First one is about the global mean temperature. So what we see there is that in all scenarios, the global mean temperature is about to increase. So that's for sure. In the RCP 2.6, it will be limited to 2 degrees Celsius, as I said. If you look at the RCP 8.5 scenario, global temperatures will increase by somewhere between 2 and 5 degrees Celsius. Now, as is shown in the results in this simulation, this is very much dependent on the location where you are. So there are regions which will barely warm up. There are many regions which will warm up between 2 and 5 degrees Celsius. And there are regions that will see an increase in temperature above 9 degrees Celsius. For example, the Arctic is going to heat up more than 9 degrees Celsius by 2100 in the business as usual scenario. So that's the first result of the simulation of the supercomputer that we can take away. Second one is about precipitation. So this is another important thing that is going to change. So first of all, we see again that overall the mean is going to increase. So typically precipitation on average is going to increase by 25%, but it depends again on the location where we're looking at, how much that's going to be. There are locations that will actually see less rainfall, others will see more, and also the timing at which it happens can shift between winter and summer. And then the third thing is of course sea level rise. Sea level rise is of course happening already. The results of the models that you should see here are sea level rise related with purely the expansion of water due to increased temperature. As you might know from your science classes, water expands when you heat it up. So, and since the globe is warming, all the water on the globe is also expanding. And that already leads to an increase in the sea level, about 40 centimeters by 2100 in the business as usual scenario. Although again, here the message is it depends on where you're looking at. And last but not least, there is maybe a factor that you're not that familiar with, and it is the ocean acidification. In fact, our oceans are slightly base, so the pH level is about 8.1, 8.2. And this has been like, it has been like this for millions of years, and it means that the ocean ecosystems have really adapted to this pH level. Now, since the oceans work as a carbon sink, so they're absorbing a lot of CO2, they actually become acidified. So the pH is actually changing already, it's dropping, and it's about to drop to 7.5, 7.7 by 2100 in the business as usual scenario. When the water becomes more acidic, it means that all life forms in the oceans that are based on carbonate, like all shells, coral reefs and so on, they basically will start dissolving, and this poses a huge threat. What is most important with those models and with those simulations is that we keep in mind that they're far from perfect. So the results we get out of it are only as good as the models we build and the proxy data we can put in there, that we can feed to the models. So it's really important that we keep investing in science, that we keep investing in further data collections by ice cores, by tree rings, and so on and so forth. Since I have been looking at this data, I've been looking at those results for years now. I've been following up the climate science. It's really exciting to be able to go in the supercomputer that has been running those models. So that was really exciting for me. I hope you guys liked this video. If you did, hit that like button, subscribe if you want to follow me during the climate journey. More cool stuff is coming up soon, and until then, stay curious. Cheers!